In this video, let's learn about partial fraction decomposition. So here's the example. We're looking at the integral of 1 over x squared minus 4 dx. So what could we do here? There is a possibility of doing a trig sub. I think it would be like tangent inverse or something like that, but let's just not do that. Let's try and solve this out with some new techniques, partial fraction decomposition. I don't know if you guys are familiar with this yet, but we're going to go into it in depth. So the integrand is 1 over x squared minus 4, which can be simplified to 1 over x plus 2 times x minus 2. Okay, so what exactly is partial fraction decomposition? We're kind of going to want to split this fraction into multiple easier fractions to integrate. So for partial fraction decomposition, if we look at an example like this, x minus 5 over x plus 3 and x minus 5 over x plus 5, to add these two things together, we get a common denominator. So we get some common denominator over some numbers. And right now we're kind of starting with that and then working backwards to get to the two separate fractions that are going to be easier for us to solve with some of the integration techniques we already know. So I'd break it up into some smaller fractions, and it could be 2 or 3. But let's kind of get into how we would do this one. This one's on the simpler side because we have linear terms in the denominator. So let's take a look at how we would tackle something like this. Two simpler fractions, yep. So we want to integrate those. As said before, we look at the integrand and we simplify it down, or more so like expand it. And now we're introducing two fractions, one with a constant a above it and one with a constant b above it. These a and b terms are something we're going to be solving for, and we'll show you how we do that. So let's take a look. We're going to multiply both sides by the denominator on the left hand side. So that's x plus 2 and x minus 2. And what's going to happen is that's going to cancel out the x minus 2 and x plus 2 on the bottom of the left side and leave just 1. And that's going to cancel some terms from the a term and some terms from the b term. So we'll end up with something like a times x minus 2 plus b times x plus 2 equals 1. So let's take a look how that unfolds. We're just canceling out these things. And we get 1 equals a times x minus 2 plus b times x plus 2. And now we're going to distribute in the a and the b. And we get ax minus 2a and bx plus 2b, sorry. And I don't know what happened there. We're going to look at this and move that over to the next page and kind of look at what we're going to do here to solve for a and b. So we're going to start by looking at the x terms. Try and imagine there's an x out front of the 1, like 0x. So we have an ax term and a bx term and a 0x term on the right. So we could say ax plus bx equals 0x, or a plus b equals 0. That's not too bad. And then let's take a look at the constant terms. That would be the negative 2a and the 2b and the 1. So we could say 2b minus 2a is equal to 1. Now what we have is a systems of equations with two variables and two unknowns. We can solve this in a multitude of ways, but I'm going to go through and solve it with substitution. I solved for a in terms of b up there by subtracting b on both sides. I'm going to plug that into the other equation. So we have 2b minus 2 times negative b, and that gets us 4b is equal to 1. And we have b is equal to 1/4. And we can simply plug that back in to the original expression, and we get a is equal to negative 1/4. Now with a and b solved, we want to remember what our original fraction was with a and b. It was a over x plus 2 and b over x minus 2. So now we're going to plug in the negative 1/4 for a and the positive 1/4 for b. And we get these two fractions, and that's going to be equal to the original expression that we had before. And this allows us to separate the integrand out into multiple fractions that are easier to solve with integration techniques. So it's going to be equal to 1/4 over x minus 2 minus 1/4 over x plus 2. And the negative 1/4 is a, and the positive 1/4 is b. And from here, we can separate those two integrals into two separate integrals. The integral of 1/4 times 1 over x minus 2, and that's dx, minus the integral of 1/4 times 1 over x plus 2 dx. And then we take the constants out front, and we're going to be solving using u sub. So we're going to declare u in the first case to be x minus 2. So du is just going to be dx. We get 1 over u du, and that ends up being natural log of u. So we plug in u, and we get 1/4 ln x minus 2 minus 1/4 ln x plus 2 plus c. With these, we can simplify using log rules. We're going to be factoring out the 1/4 and then setting those subtracted to each other. And if you remember log rules, if you're subtracting them, it's like dividing. So we get 1/4 natural log x minus 2 x over x plus 1 plus c. And that'll be our final answer.